Hi, good afternoon everybody. I'm Alan Beresford, MD of EcoCooling. Next 20-25 minutes with Jonas from ETIX. We're going to go through a case study which hopefully you'll find interesting about how we put together and delivered what we think is a very interesting project out in Iceland to support blockchain. We're going to explain some of the commercial reasons, the project planning, the engineering of it, which supports blockchain now, but maybe some of these other emerging technologies. After a brief introduction, Jonas will go through how ETIX approached the project. ETIX are a big multinational organisation, typically building data centres as joint ventures with other stakeholders. They have a specialist subsidiary which is called ETIX Blockchain, which is here to specialise. Obviously, does what it says on the tin, concentrating on blockchain. EcoCooling, maybe some of you are familiar with us. We are specialist manufacturers of fresh air systems. We've done a huge amount of work in data centres with fresh air cooling, with adiabatic cooling. We do a lot of work in the telco sector, and over the last year we got involved in this crazy world of Bitcoin mining, delivering as much as 5 megawatts a week into that sector. A lot of experience gained under what we call our Cloud Cooler brand about rapid deployment, ultra low cost solutions into these new markets. Many of you will be familiar with traditional data centers. Traditional data centers have CPU processors, servers in there. What we're seeing in the emerging technologies, including blockchain, is a move away from that into more powerful equipment, which you may not be used to seeing. You may see GPUs, graphic processing units, used in render farms and things like that. They're used in blockchain. Some of the cryptocurrencies like Zcash use GPUs. The real ultra high performance devices are called ASICs, application specific integrated circuits. These are absolute sledgehammers, 100 times more powerful than a conventional CPU, but only do one thing. These are established technology now, and the project that Jonas is going to talk about is applying building a project to house ASICs. At the bottom of that, I've just put in a thing called an FPGA, Field Programmable Gate Array. These are the devices that people like Amazon are using. They're midway performance between GPUs and ASICs. They might be the device of the future, we don't know. But what we're doing is using our knowledge from Bitcoin mining and ASIC to build facilities which can accommodate these different types of technology. So what I'm going to do now is hand you over to Jonas, who's going to talk you through the project, its objectives and its delivery.
Thanks, Alan. Great introduction to ETIX, so I won't go through that again. I'm Jonas Caino. I'm the Global Vice President for Sales for ETIX Blockchain. So we've been designing, building and managing data centers for many years now. And they're typically tier 3, tier 4 data centers globally, from Ghana to Iran to Belgium to Paris, all over the world. And more recently, we started getting inquiries from blockchain and cryptocurrency suppliers or individuals. And we kind of divide them into two types. One is the type that wants to just have to cash in on the whole cryptocurrency scenario, where they want to build a shed somewhere that's code and just fill it up and just say, look, this is us basically making money from cryptocurrency. Nothing wrong with that. But there's another type of company that actually looks at more data center grade cryptocurrency mining farms. And the reason why they want to do that is because they want to set up a blockchain infrastructure globally to take advantage of all applications for blockchain in the future. But the first real application is cryptocurrency, hence mining. So those are the companies that we started talking to. And this particular company is a Japanese firm, and they really wanted to make it big in Europe. So we suggested that we'll find a location for them. Now, location services is one of the things we do. Globally, we look for the right location. But if you know blockchain and cryptocurrency mining, location is important when it comes to things like temperature and power. Not really anything else, temperature and power. It's really about efficiency and about low cost of ownership. So we scoured the right location and we found Iceland. So this location is a place called Vikjar, which is about 50 kilometers south of the capital, Reykjavik. And they needed a particular capacity that will be filled out from day one. So it isn't modular where they need 1 megawatt and then maybe two next month and what have you. It's 8 megawatts from day one. That's it. So we had to design an 8 megawatt capacity from scratch. Now, if you know how cryptocurrency companies work, timing is always key. They want to make a decision now. They make their decisions based on what's happening in the marketplace. And once they've gone through their process, they come to us last and they say, we need it done yesterday. So we had a time frame of 6 months. So 6 months from the first brick in the ground all the way to it being operational, 6 months. A day later, we start paying fines. So we had to do it in 6 months. Now for us, that was an issue because number one, if you go to Vikjar, you know how difficult it is to get there and also the climate. So we had to really put our best guys at this and see what we can do. Now, the thing about us as a company is we have to look at the best vendors out there. We're very vendor agnostic. So our vendor management team went out there and looked at all the cooling vendors, and we came across lots of guys, and our focus at the time was design and reliability. But once this project came up, it was really about lead time, as well as speed of manufacture. So our demands were quite simple. The site has to be low cost to manufacture or create, low cost to install, and also low cost to run. The operation cost has to be low as well, clearly, but the lead time was really key for us. 6 months isn't a lot of time when it comes to an 8 megawatt site. That's 1,000 meters white space. So EcoCool was just one of several suppliers we were talking to. But then we found out there was something very, very unique about EcoCooling, and that was they've had experience in this sector, which was important to us. Many manufacturers out there, they have experience in data center sector or comfort cooling, office sector. But this is a new sector, and EcoCooling just seems to have a wealth of experience, which was key to us. The product that our customers specifically wanted was the A9 machines. And if you know about the A9 machines, they're about 1.4 kilowatts per machine, and it's quite compact. So we needed a supplier that can manufacture the right, not just cooling capacity, but also the right rack type infrastructure that can house these machines. But what's important to us, as I said with location, is one is we don't want a supplier that can just come along and then try and install this for the complete duration of the installation. We needed someone who could teach us, and then we do the installation ourselves. And it would be a plug and play system. So we don't want to be on site and then we start figuring out what to do. There are problems and we go back and forth. We couldn't afford that. We couldn't afford the time and we couldn't afford the cost. And so with EcoCooling, it was a case of just come in, install the first module, and then we will install the rest, which took a month. So that project went very well, 8 megawatts. We have a second site, which we've just completed about 2 weeks ago, and that was 35 megawatts. And that was north of Iceland, a place called Bonduras. I'm not sure if I pronounced it right, but I say it's Bonduras. And that's north of Iceland. And again, we came back to EcoCooling because they did such a good job on this particular project. We thought 35 megawatts we'll carry on doing. We're still looking at growing our wattage to up to 250 megawatts in Iceland, and it will continue to grow. So, what did we have? We didn't have a shed, even though it is cryptocurrency. This is the basis of the blockchain infrastructure, which would affect insurance, it would affect automotive cars, it would affect IoT. And so we created a world-class data center facility that is tier 1, as opposed to, if you know your Uptime Institute or TIA, it isn't redundant. There are no UPSs or redundant systems. We rely on the geothermal and hydroelectric power in Iceland, which is actually quite stable. And we see it as extreme engineering due to the time, due to the amount of kilowatts per rack, which as you can see, it's 70 kilowatts per rack. And in total, 8 megawatts, 1,000 square meters, so it's 8 kilowatts per meter. The good thing is, it is flexible. To us, it's just there, but if we need to change things around, depending on SLA, depending on obviously the cryptocurrency market, we can. And it says here, installation time is 16 weeks. Well, it wasn't. Installation time was 4 weeks for cooling, and 6 months for the complete entire project. So it went well. That's the end result. Thank you very much.
Thanks, Jonas. I'll just now very quickly go through some of the engineering principles we use. First one, controls. As Jonas said, these guys are running fast projects. They've got the minimum cost objectives. So the one thing's building equipment, but the other thing is controlling, creating a control system which is remote access, remote configurable. What Jonas said is we went and trained them how to do the first installation of the cooling and the rack system, but we set up the first control system, and then for the remainder of the project this has been all remotely commissioned, because running projects is complicated. You don't know about timing, you don't know when people have got to be in Reykjavik. So tomorrow, can we commission pod 3, row 3, whatever, and do it all remotely? That's what our customers are wanting. Also, resilience is a cascade of failure. If one control item goes out, everything cascades into a controlled, stable system. Sizing. One part of the experience we have is we understand how much air these systems need. It sounds really simple, but it's very difficult to get any sort of reliable information from suppliers of equipment. So our years of experience help us put these models together which balances power, space, racks, airflow. So you see, for this 8 megawatt building, we're putting 500 cubic meters per second of air into this building. That's a huge amount of air. We move the air through the building at about 40 kilometers an hour. This is, as Jonas said, this is extreme engineering. Okay, so with our mathematical models, we understand temperature, power, airflow, performance, to give these guys not just a low cost operation for cryptocurrency, but also stable temperature, stable humidity, so it maximizes the reliability of equipment. Because a lot is happening. All these new technologies, 5G, Internet of Things, artificial intelligence, blockchain, social media, cloud-based gaming, these are all technologies which are potential users of remote processing capacity. We're not quite sure which is going to be the first. Cryptocurrency has been and slightly gone, but there is a strong belief that particularly the 5G was going to drive enormous demands for this style of very low cost, very rapid deployment operation. And just to put this in perspective, where we think the market is going from what we've learnt about cryptocurrency, if you've got a traditional data center which might cost, let's say, $5 million a megawatt to build, we may be heading towards facilities now that are only costing $500,000 a megawatt to build, and in the future maybe using containerized system as little as $350,000 a megawatt. This is extremely low cost. Because it's low cost, it's simple. Because it's simple, it's also reliable. Also, just to put this in perspective compared to a conventional data center, this is 1 megawatts of space of ASIC miners. That's 1 megawatt of space for what would be a standard 2.5 kilowatt average load per rack in like a UK co-location. So you see the difference in size. Also, in processing capacity, this is doing 100 times the work of that. And so you understand the whole scale of things, and the brutal processing of this is it's just a massive step change in this sector. What we're also seeing in the market is a rate of adoption of new technologies. I won't go into this in too much detail, but these are all graphs of use by end users of ranging from cars and telephones, washing machines, and in the past it's been really slow. But if you go to the new technologies on the right hand side and see how fast we've got the adoption of tablets and mobile phones, we're seeing a stratospheric growth. These guys aren't just going to need to have capacity, they're going to have to respond to it quickly. So the sort of projects that ETIX are putting together are about rapid response to these emerging markets, which leads straight into this edge data center debate, which there's been so much talked about in the exhibitions in all the halls so far this year. How do we provide this deployed data center using these low-cost, rapid deployment technologies? And you will see that the current ETIX building is a midpoint, potentially going through to maybe a containerized solution for a true endpoint of data center. There is also an environmental issue. When the sector has got a big issue with the amount of energy it's using and its environmental impact. By building a very efficient data center, linking it to renewables, in this case hydro or geothermal, creating buildings and systems which are high degrees of recyclability and intelligent management to be very, very efficient, and then not using refrigerants, and we're not using batteries, and we're not using lots of concrete, and reducing our CO2 levels. Overall, we can make a very environmentally responsible system as well. Big guys being eaten by little guys. What ETIX are doing is providing an infrastructure which, if you're not Amazon or Google or Facebook or Oracle or Uber, you can now have a facility which is equal, if not better, to the total operating cost of what the big guys do, without having to have facilities in hundreds and hundreds of megawatts. So they're creating a facility of low cost and availability to allow the masses to enter this market and be competitive. Low cost, efficiency, speed. Hopefully that's explained a few of the principles how, using this rapid build, plug and play, simplistic, low cost way, that EcoCooling and ETIX have worked really, I think, superbly together to create a world-class project which we're very, very proud of. Right, questions? Mike. Jonas.
Hello. Question. My knowledge is now 3 months old, but in that time, Bitcoin mining consumes like 7 terawatt hours per year. So that's approximately the same amount of switch per year. And now you want to waste that energy. Why don't you want to reuse it? Sell it to the customers, like in Nordic country, also in Iceland can do it. So that will bring you money and bring that energy back to the customer.
Very valid question, and it is a perennial problem within the whole sector. You quoted terawatt hours. In a different way, we think data centers consume about 5% of the Western world's electricity. There's only a few isolated examples, particularly like Stockholm with their district heating scheme, where they actually reusing the waste heat. Everyone is looking at options for doing this. We are involved in projects where we're taking the waste heat to dry biomass, which then can be fed back into the system, maybe back into the power generation of the data center. We're also looking in Denmark of storing waste heat in underground systems, which then can be put forward into greenhouses and crop growing. Currently, the sector's only scratching the surface, but it's under massive pressure to do something. All we can do at the moment is take a normal data center, which would maybe waste typically 30, 40, 50% of the energy it uses on non-core activities, on cooling and UPS losses, and we reduce that from 50% to about 3%. So we're reducing the overall usage, but we currently haven't got that holy grail of heat recovery.
Just to add to that, you're absolutely right. Our design team are constantly battling with this issue. So we have two ways of looking at this. And one is that to make the data center as efficient as possible, we're constantly pushing the efficiency boat out there so that there's less energy to sort of worry us in terms of waste. But the second bit, particularly with Blondeurs, is we're looking at district heating for the environment. So those are the sort of two areas we're looking at more.
Three minutes, more questions. Any more questions, anybody? Okay, guys, thank you very much for your time. Hope you found that interesting. If you want to explore this any further, come and see us on our stand where we exhibited. What number is? And we've got a video of the operation there as well. Come and see us on our stand. Otherwise, thank you very much for your time. Thank you.